one of the most mysterious entities studied by physics. The more we learn about light, the more difficult it is to imagine our lives without it. Every day, every hour, and every second, we face this or that light phenomenon, and sometimes don't notice it at all. Despite the omnipresence of light, scientists from all over the world started to seriously consider its nature only in the 17th century. Let's try to find out what light is. The first ideas of the nature of light belong to the ancient Greeks and Egyptians. The phenomena which they could observe during the experiments have been studied by such part of modern physics as geometric optics, which focuses on light beam as a basic concept similar to the geometric one in terms of its properties. In ancient times, it was simply a question of whether or not this ray of light was discrete as any other form of matter. Advocates of various theories argued throughout many centuries until two major theories of light, corpuscular and wave theories, were proposed. One of the main followers of the corpuscular theory of light was Isaac Newton, an English mathematician and physicist. He considered light to consist of smallest parts which we now call photons. Any luminous body emits them in different directions. They travel in straight lines, and when our eyes detect these photons, we see their source. Nearly at the same time, the Dutch physicist and astronomer Christian Huygens introduced his idea of light represented as a wave. In his opinion, light waves spread out from the source in different directions, just as water waves generated by a stone thrown into the water. Reaching the human eye, waves as well as corpuscles let us see the light source. Physicists who rejected the wave theory of light had been trying to find contradictions in it for a long time. For example, it was not clear why light did not bend round obstacles like a sound wave. Huygens assumed that obstacles that were used in the experiments were too large for light wave, and for this reason, bending of waves round obstacles was impossible. Then, a new question arose. If the physicists of the 17th century thought that space was empty, and waves, for example sound waves, did not propagate in empty space, then how did light from the sun reach Earth? According to Huygens, all material bodies and spaces around are occupied by a super-thin substance called ether, and the light spreads inside it. But at that time, nobody could answer the question about the nature of ether. As it turned out later, ether didn't actually exist, but in the 19th century, this fact did not prevent the wave theory of light from the growing popularity. However, the nature of light remained a debatable issue. The strength of the winning theory was questioned at the end of the 19th century, when Michelson's experiment showed that ether didn't exist at all. Again, the nature of light became one of the most important issues in physics of the beginning of the 20th century. Albert Einstein, a German theoretical physicist famous for his theory of relativity, managed to resolve the existing issues. Thanks to Einstein's second law of photoelectric effect, which said that the maximum kinetic energy of the emitted photoelectron depends on the frequency of the incident light, but is independent of the intensity of the incident light, Max Planck's quantum hypothesis was proved. But the scientists faced the question about the nature of light again. Thus, the principle of corpuscular-wave duality of light consists in duality of light's behavior. It can both have wave properties and be represented as a stream of particles. It was extremely difficult for the human imagination to believe this fact, as it was based only on the ideas of the macrocosm we are living in. It didn't also become clear whether there were any other representations of light not available for the human imagination. So, what is so revolutionary about this mysterious principle of corpuscular-wave duality of light? And what is the practical and theoretical value of one of the greatest achievements of the mankind? Firstly, the principle of corpuscular-wave duality has formed the basis of the quantum mechanics, which rose at the beginning of the last century and opened the new horizons of modern physics. Secondly, the development of this theory of light has led to the hypothesis of de Broglie, according to which all material objects of the universe have both quantum, or corpuscular, and wave properties, and the length of a wave and the impulse of a body are connected by the de Broglie formula. Finally, the hypothesis of de Broglie was followed by the possibility of diffraction of electrons, the phenomenon that all modern world of electrical engineering is based on.